please don't make mistake about that. And your college name should also be right there. And yeah, other details like your referee email ID, phone number, name should also be right, because we are going to start connecting with them as soon as we start getting responses from you guys. So please fill the information correct. And also we are going to ask you about your commitment for this internship. If you are going to get selected, then we want your 100% dedication for this commitment, for this internship. This is what we want in that form to be filled. In case you are engaged somewhere, or the final year student have their joining in a company, so I think it's good to say you don't agree that you will be available for whole time, because then it will not be nice for the other team members. So these are the things. Actually, this information is required, and for taking you to the next level. So you'll start receiving individual emails with the details that you have filled earlier to cross check, and then you have to validate it in that form. So yesterday, YouTube chat was not available. We are making it enabled today. Many of the students who are not part of this first list, they are watching the session on YouTube. So we'll enable the YouTube chat also. But all you guys should write your comments in this chat. So because there will be multiple windows which we have to manage to get the answers. Um, so. Uh, Dharmender, Mr. Syed has joined. Yeah, I see Yogesh and
Not me, sir.
okay. Hi
Yeah,
Yogesh.
good morning. Yeah, good
Good.
morning. Hi, Dilip.
Yeah, good morning.
Sai sir is about to join in the next few minutes.
Okay. Janki, can you write what is the doubt? I forget what same doubt. Sir, same doubt. What does it mean? Sorry. What? How many referee details we can give, sir? And can we change or add another referee? Yeah, sure. You can do that. In this the Google form that we are going to float, you can fill the referee detail whom we'll be contacting now. Okay.
Dheeraj, can you unmute Mr. Syed? He's online.
Yeah.
Thank you. Good morning. I was putting messages on the chat box. Can I also get the permission to share, please? Just want to check.
Just, sir, I'm granting permission. Just a minute.
Thank you, sir. Appreciate it.
Now you can present.
Wonderful. Are you able to see my screen?
Yes, sir.
And can you let me know when we can get started? So I'll do that accordingly.
Yes, so we can start. A very good morning to all of you. We have Mr. Syed with us today. He will take up DFMA demo casting, sheet metal, and DFA demo plastic and machining.
Are we doing that today? I'll be doing it tomorrow. Okay. Good morning, everybody. And again, can we do a quick check of a few things? One is your chat box responses. So if you can hear me, give me a shout on the chat box saying a yes or a okay or a good morning or whatever. Thank you so much. And as part of the recap, a few things. Is there anything that struck you from what you have gathered yesterday? Please take a minute to type it out in a very short brief. If you don't, then what I will do is I'll just run you through a quick one on the tool, and let's go to a few more commodities using the DFM concurrent costing tool. And I would like to show you case studies from the industry as well as some academic case studies as a part of today. So I'll probably be helped with my colleague Balaji, who would probably do the sheet metal part. Balaji, are you already there? I can't see you. Yes, a quick recap. How can you finish implied design iterations? So let me give you some example by showing you something so that you get a feel of the different approaches. I'm not sure if I have it here. Let me see if are you able to see my screen? Hello, able to see my screen? Super. So let me start with I'm going to show you 2-3 different approaches to solving or using DFA tool to carry out an analysis. Okay, can you see my image of a set of parts, right? Guys, thank you so much for the chat box thing. Now focus on my screen, please. Are you able to see that I have a picture here of a sub-assembly, which is a steering pump. The steering pump is used in very large SUVs, an automobile product. Now, this case study refers to a possibility where this OEM, okay, he gets a supply from his vendor, but the vendor is not sharing all the engineering information like the drawings, the details, the materials related to this particular product that is supplying. But the OEM wants to know what is the actual value of the cost of these components. They're just been buying historically by negotiating with the vendor. They don't have a scientific engineered cost for this. So this is an activity wherein what we do is we do a tear down analysis, which means you have a sub-assembly, you tear it down, keep all the parts, and then you reassemble. In the process of reassembling, you have a cross-functional team. The cross-functional team may be somebody who understands castings, somebody who knows how to buy regular off-the-shelf components like bearings, bushes, washers, okay, and sit down and help to build a overall product structure with assumptions that maybe this is how the product should be assembled. Many companies do this reverse engineering activity, value engineering, using something by doing a tear down analysis. This is something you could also do with the DFA tool. So you could do it in an assembly sequence. You can also do the disassembly sequence. Sorry, somebody has a question. Okay, you would use, like I said yesterday, you would do disassembly when your challenge is, hey, how should I service this product in the field? How should an engineer or service engineer disassemble and address a maintenance or a warranty or a issue or a service problem. So that time you may want to do a disassembly, because what happens during assembly in a factory with the tools and the tackles and the procedures and the steps may not be the same way in which a field engineer or a field mechanic or a field technician would do the same, and he may not have the same kind of tools to do a reorganization of the parts when he wants to disassemble and repair them. So you can use DFA to do both these attributes. This is option one I want to show up to you as part of the recap. Second thing I want to show you is you can also do, let us say, if you had just a drawing, sorry, not this. Sorry, this is now this is what I showed you there was a mechanical component. This is an electromechanical component. It's got sheet metal parts. It's got PCB. It's got wire harness, plastic components, and so with a 2D drawing like this, also you could do a very decent DFA analysis. So even if you're not somebody, the cost for assembly and disassembly are the same, sir. Not necessarily, Praneeth. That is what I'm trying to tell you. If you look at assembly in a factory, they may have a process. They will have tools that help and aid them to do this much faster. Okay, but in the disassembly, which is like on the field, you can imagine you are maybe a motorcycle or a scooter mechanic. He doesn't have the same kind of tools. But he has to disassemble, let us say, your tire for a puncture or the engine for this. His tools and tackles are different. So his disassembly should be made much more easier. That study can be done at the product design stage. Many successful companies who do that. One classic example is the old version of the Volkswagen Beetle. You know, with a 13 size spanner and a screwdriver, you can almost dismantle most of the parts of that particular car. So designing something like that, it requires some intense upfront thinking during the assembly sequence processing. So this is one part of the recap I wanted to show you about. And today what we will probably be doing, I'm just got another 4 more minutes. Does the TFS suggest, Ashwin, this tool is not a intelligent tool. This is a knowledge tool. So if you have a product like this, I can look at redesign based on this product under these categories for suggestion for redesign. The software will say under this assembly category of problems, these are the ones that are offering the challenges, and this is the penalty time that they are contributing. So what I would do is, when I look at, for example, if I'm looking at this category 1, I'm looking at those candidates that we as a user have marked as unnecessary or redundant component. I'm looking at those components which have large time contributors. For example, this guy, 24 seconds, M3 nuts. So I go back to my questions and figure out what is this M3 nuts doing there? How many quantity do I have? How much is the time that it is spending? What it is there for? Okay, and then I will look at challenging that as to how is the better way to put and replace that M3 nuts. That will be creative design thinking, creativity that is ingenious to us as human beings. But what the software can do is it can create a rapid feedback of your design intent. I'll just do that in a minute. I'm going to make a copy of this. I'll paste it. I'll call it rename, and I'll say original dash Ashwin idea. Okay, and I'm saying, maybe there's a possibility instead of having this as nuts, we can rename this. See here, I'm just doing my idea creation here. I'm going to double click this and say I'll make it a M3 size snap fit. I don't know whether it's a suitable thing. So I'm not going to have it as a threaded fastener. Maybe I'll do a snap fit operation with 3 snaps. It's in my imagination now, but I do not know what the impact of this. So I can do this impact analysis by going here. I'll look at this process time. I'm just going to take the original and the Ashwin idea, which I just now created, and look at them. Sorry, I need to regenerate the file. Dash 25 May 2021. Saving this. Okay. Let me go and look at that. So what I'm trying to tell you is, on its own, it does not recommend iterations. It gives you a feedback of your design intent. Okay, and here, as you see, the impact of the old to the new, this is going to be your change of your design iteration. So 177 seconds is going to be probably 174, and my design index is going to change up so slightly. What I just did here was, instead of a screw, I changed it to a snapshot design, right? So I can get rapid feedback of intent like this, which is what we could probably do. Okay, 2 more questions before I go on to the session. Hang on, improvement. How can you do 2D drawing like that, sir? With software? No. This 2D drawing image is just an image of the product. This will also be a drawing. It does not read from the drawing. I'm just using this drawing as a reference of saying what file this product is. This doesn't read from a 2D drawing. Only 2 answers assignments are shared, no DFMA. Guys, let's talk about DFMA related questions here. I'm looking at your questions in the chat box, right? So please keep your questions focused on a recap kind of a.
Sir, I have one question. What is the difference between disassembly order and assembly order?
I think I already explained that. This assembly order is more on the factory level, which may be having more good tools. Disassembly order would probably involve having a full product where a subassembly is inside the product. Imagine like a car is already available at the mechanic shop. He wants to access, say, the alternator. The access for the mechanic to the alternator in a disassembly is a disassembly sequence. He has to open the bonnet. He has to then keep the bonnet locked in a standing position. He has to remove probably the front grill, then go and reach access. This is not the same sequence of the assembly when the product is built in the shop floor in the factory. Okay, so the challenges in a disassembly sequencing or removal of an item to reach it may be different than assembly sequencing of the same product when the product is built. I hope that answers your questions, Mayank. Can we export component specification from other software? Yeah, I will show you that if time permits. Here we have an opportunity, like I said yesterday, that we can import bill of materials. So you can import the bill of materials in a text or a CSV format. So I can even import Excel formats like you can see here, and we can also do text formats. We can probably give you content in as training manual, which will probably have this information. Where have to upload our assignments? Where can we get the file for this? The files have been already sent, Shanmuga. Balaji has sent an email to out the team. They have it. Okay, so wonderful, guys. Meant for repairs. Yes, Himanshu. Disassembly is meant for repairs, maintenance, warranty, service, and other purposes where in the life of the product, right? Imagine a helicopter. In the life of the product, how much is the life? 20 years. You have issues like disassembly to do repair, maintenance. So how do you plan for that kind of disassembly? A good design would have an assembly as well as disassembly, which will be as simple as possible with the most minimum tools. Is the assembly cost fixed or does it depend on? No. I mean, let us say you have a product here and you disassembled in Nepal. His labor rate is going to be different, right? How can you add new operations? DFA? Well, there is a library. We can build operations inside it. If time permits, we will try to show you that, or we'll share some content if you ask us separately how it will probably be done. We will show that to you. This is actually much for a 6-hour content. The idea is to give you get started. So thank you so much for that attention, and it was a good recap. Shall we get to doing our first of the commodities, which is doing the DFM for a part? Okay, so let me time out from here. And no. So just let me know if you can see my screen. If you will have multiple systems, you can probably do this simultaneously, or if not, please have a watch my screen so that we can learn from this, and then you have the PDF documents on this exercise. You could probably take it from there. Okay. Now I'm going to analyze one of our motor parts, which is this guy, this base part, okay, as a component for casting. Okay, so I'm going to give it a name. I'm going to do two approaches. I'm going to do two approaches. One is I'm going to start out this exercise like as if I have only a concept and I will do a quick analysis. Then I will take up a CAD model. Is that okay with you guys? So that I can show you both aspects of how to use this tool. So I call this as the cast, the base part. Sorry, base part. And that's the name. And life volume. I just want to make a few 100 pieces. That's what's my objective. Now, generally, the DFM tool is designed so that anybody from the conceptual stage design can be able to get estimates right up to the production engineer who may have accurate inputs which he can give to build his cost model. This software graphics user interface is designed with that in mind. So just like we are in DFA, we give an overall geometry of our part as cuboidal or cylindrical. You can start out a DFM analysis by saying what is the approximate envelope shape that your component occupies. See my screen? So what is the maximum dimension, and is it a hollow component or a solid component? So this helps to do some internal calculations. Why? Even if you don't have engineered data about your idea of the part, you can still get good cost estimates when you're doing conceptual work. Do you understand what I said? If you do, say yes. If not, you can ask the clarification. I can get ahead to answer them. Great. Thank you so much. So I'm looking at my part, and if you see, I'm going to refer to this part again. Guys, do you have the dimensions of this part in your in the PDF, so I can use it for reference? Just give me a second. And just opening up. Okay, I'll just take an estimate here from the CAD model. I'll come back to this. So I'm going to take assume the value for the for this base part. I'll say it is a 25 mm height, about 70 mm wide, and about 100 mm width, and about 3 mm in thickness. See, I'm doing this at a conceptual level, and I start out with doing three important inputs in this first window. One is the life volume, your choice of envelope shape that closely defines what your component final geometry is like. This is the geometry of your parts, okay, and an average thickness of that part. I select the process and material selection window. This will come up. Now I can choose what I want as the particular process that I have intending to make this with, and what will come up is these two choices on the right hand side. Of course, your software will not have the Reeves project. You will have North America and China database. Now, why do we have this? This is a database that has been standardized over the last 3 decades. But where customers deploy this, they use this database and they build their own customized, localized database for their own activity. We'll talk about that in a minute, but right now you could probably refer the default that you may have in your. Don't worry about these projects, Himanshu. That's my private projects. It is somehow get copied here in my presentation laptop also. BDI means Boothroyd Dewhurst Incorporation. BDI are the people. That's Dr. Jeffrey Boothroyd and Dr. Peter Dewhurst, the two folks who started this concept of measuring cost at the design stage. So Dr. Jeffrey Boothroyd and Dr. Peter Dewhurst are from the University of Rhode Island, and they started out this measurement technique for measuring cost at the design stage in the 1970s. They started this activity to help automotive and aerospace businesses to measure cost at the design stage. Today, we have it in the form of a computing tool. This tool is over 36 years old. So that amount of database has been documented and standardized in our software, right? And it's the number one in this methodology that is used by Fortune 1000 companies. Okay, thank you, Janaki. So die casting operation, and let me select a material. So when you make a selection that has certain limitations from a manufacturing perspective, what it will do is it will give you the recommendations like the same. Hey, you have selected a production quantities less than 10,000. It's most likely to be uneconomical. It is okay. Maybe I want to do a academic analysis here, so I can say okay, and I'll say yes. And what has come up now, ladies and gentlemen, is the overview of the process related to the combination you have selected. For a given geometry, you have selected a process of casting and you selected a material. What comes up below from the software automatically is this data. That is the process related parameters, the process machine that can be utilized for an operation like this. These are the list of machines right now, but it is selected the most ideal machine. Okay, what the software will do when you give a geometry for carrying out a costing analysis or a manufacturing review analysis is it will go up and pick up the most ideal machine. Why does it do that? Because this automatic selection is always on in our tool. Unless you don't want it, you can unclick this and go and probably select another machine. For example, right now I can go and say change the machine. It will bring up all the die casting machines that are listed in our library. I can go and select some other machine. Okay, when will I do this? I will do this when maybe in our lab, I don't have such a small machine. Maybe the smallest machine that I have is some other tonnage. Then I can go click on that and use it. And what the software will do is it will help me to build the cost model. It will help me to build that process rate and the process cycle time based on that selection that I have made. Of course, like I said yesterday at the start of our presentation, the impact of these quantifications is in two important parameters, time and cost. So you get a feedback of your selection, as you can see here, because you selected a more higher wattage machine. It is saying 30, 28, and 37 is the new timing, and the process cost is higher, and the overall cost is this much. Janaki, the reason why the machine library last name is maybe your default settings. It would probably be in inches. You can go to this analysis, set units, and you should select the variables instead of metric. You should instead of English, you should select it to metric. If you do that, and say use this default for all subsequent analysis, it will be locked in there. Go back to your, you'll see now the inches has been converted to mm. Then now you go back and feed in this data correct to mm. Just watch out when you start your analysis for the envelope dimensions. Yes, Janaki. Wonderful. In the selection process, it shows a warning like machine library does not contain a die casting. Yeah, that's the reason. How do you select another machine? Go to the machine, right click, you get a list of things. You can go and select machine, change machine here. The machine library comes up. Okay. Now, a few things that I would like you to know that this is conceptual. So let me just rename this as conceptual. I'm going to show you and teach you 2-3 things in the next 40 minutes in this session. One is how we do conceptual, how we import a CAD, and how we look at an important feature called geometry calculator. This little blue and yellow orange box. In our terms, it's called a geometry calculator. How to use this is what I'm going to sort of also show you. So I'm going to show you in the conceptual stage, and I'm going to show you in the CAD imported stage. Okay. Now, if you remember again, that does not mean all that I'm showing to you. If you do it thoroughly, is what you can do an analysis. That's not the case. Whatever you know you do, you will get that level accuracy estimate. The more inputs are right, more better is your prediction of your cost. More better is the prediction of your cycle time and material rate and so on and so forth. Okay, so that's how this approach is. Now, let me show you a couple of things that can impact how you build your product. For example, if you remember, we had selected 100 as our life volume. Imagine if this was an academic project, I would want to do all the 100 in one shot, right? So I would say in this basic data, it has said taken the default as 12. What it's actually done is it is taken the 100 and divided by 8 as 8 batches. That's why you're getting 12 over there as a number. But what if I want to make all the 100 in one shot? Okay, I'm just showing you how our selections impact cost. That is what I'm showing you here at this conceptual stage of our analysis. I say 100 and I press on calculate. Watch what happens to the bottom left hand corner. This is our previous, this is our current cost. Okay, what has happened you see here? Because I'm making more pieces of that product in one setting, the setup cost, instead of getting amortized over 12 units in the previous case, is getting averaged over 100 units. That's why this cost, you see how it has dropped? Yeah, exactly. Increasing the batch size reduces cost. Now, while we know that hypothetically, what the software is actually doing is pinpointing to you the actual value in rupees and actual time that you could probably save in terms of doing that. So what was the 320 rupees item will now become a 279 rupees item. This is the cost of producing it, right? Now, let us go and look at some other opportunities. Since it is a small batch, why should I do an automatic? I don't have automatic, let us say, in my IIT Rupa setup. What if it was manual? How does this impact cost? I'm going to click on it. What's going to happen is the process cost is actually higher, if you can see it here, because it's a manual process, so it will take more time. Okay, even your rejection rate is going to be slightly higher, but because it is a manual process, you don't spend so much on the initial automation, and that's what will lead to your cost becoming here, because your setup cost in manual is also lesser. Sir, could we place one or more parts alongside the part we are considering cost reference purpose before even finally making it in the software? Could we place one or more parts alongside the part we are considering? Yeah, you can. So you will take out all of that part geometry as your overall volume in your analysis. For example, right now I've got this as my volume. I can say this is not my volume. I have calculated maybe perhaps in my CAD model what my volume is. I can give that new volume. I'm just typing an arbitrary number here. Okay, because those new parts will add up new volume, and the new volume multiplied by the density of the material that I've selected, in this case aluminum, will add up to the weight. So I just keyed in a number, I press on calculate. That's going to be your impact, Avantika. I hope you're getting our answer. We are doing this at a conceptual level. You could do it even more clearly if you had the CAD data available. So in this part geometry, yeah, it did increase the process cost, but it reduced the setup cost because it is manual. That's how we got this change. It did increase the process time, but the setup cost came down. Correct. So rejection rate is something that is captured in the next stage, which is in the die casting machine. Right. So if you have a rejection rate here, right now it is set at 0.05, then you get these kind of values. I'm intentionally selecting it to a higher value. Let's say the rejection rate is 2%. Okay, the impact of that will be like this. Okay, so good that you're asking these questions. You know where to look for this information. So I would recommend when you out exploring this tool, look at these attributes along this, and you will probably be able to find out what items that you will be impacting. So you can play around with them. For example, right now I've made these changes. When I make a change as a user, and if it is not a default value, it will show itself in yellow color. I have a choice. I don't want to do this. I want to go back to defaults. I can right click. I can say unlock the section. The whole of them goes back to default values. I can click back. I can see what my previous default value settings are. Okay. Sakshi, your question is how come it gets rejected? The possibility that while getting formulated, maybe there is a blowhole, the cooling was not correct. There was a change in the ambient weather. This could lead to that particular batch or that particular cycle having a rejection. That's how you would probably get rejection, even though the process is the same. Right? What does percentage rejection mean? Depending on how the process is set up, there will be a measurement of, for example, in a batch of so many. Most likely, while working through the day in an 8-hour shift, we see so much items are not meeting the complete inspection and passing through the inspection. That is the rejection rate. Okay, so you will either document it or you can create a what if scenario. What if my rejection is 1%? How much of money will I actually lose because of the rejection parts? And how much should it actually build into my cost of building the component? If you need a large batch size in our design, how can we control cost? I didn't get the question, Ikansh. If we need large batch size in our design, then how can we control cost? No, it depends. This is you're creating your situation. If you're creating this scenarios, how does it impact your cost? You're getting that understanding upfront. That is what you are using this tool. Did I answer your question, Ikansh? How do you know what value to add here? Don't. That's what I'm saying. What you're seeing here are basically some of these values are a standard in the industry, but this is not what I would probably use all the time. If I give this to my company's production guy, he'll say, "Oh, you only make 100. Why you want to make in batches? We'll do all of them. Since it's a casting component, we can make and keep." But these are business decisions in a company. I'm not teaching you this like as if you're going for your academic project or your internship project alone. I'm making you or showing you things that how this kind of decisions are made also in the industry. No, batch size does not mean larger machine. And keep batch size means instead of making 12 at a time, I'm going to make all the 100 on a time. Continuously, one after another. That's what it means. Batch doesn't mean all the 100 in one shot. Okay, we're coming to those details. Just have a look at it. Where is that batch size here? Even though it is 12, or okay, you see the number of cavities here. It is 1. Can you see my where I'm rotating, guys? You ask me questions related to what I'm showing you, then it'll be good for learning. If you jump the gun before I work, then it'll be okay. So right now it is cavities is 1. So even if I make it 100, and if I do a calculation, right, you see the cavities is 1. Increasing, if you increase the wax, if you increase these cavities, which means instead of having 1 cavity to pour and make 1 casting, if I make it as I undid this automatic selection, if I make it as 2 cavities, the impact of that would be on the tooling investment. Just watch. You see, and your tooling cost is going up, and your per piece cost is getting high. You know why this reason? The reason is because you have a very small size of 100. Instead of 100, if I change this to a 10,000 right here, the impact will be entirely different. To come from 436, it's dropped to 10 rupees, even though the molding cost is high. What does it mean? The mold is the same. I spent 43,000, but instead of making 100 out of them, I'm making now 10,000. So the 43 gets divided over 10,000 pieces instead of 100. So this impact of playing different what if scenarios is what you can do with the tool. Do you get it? If you get it, say yes on the chat box. Okay, so use this tool. You know what, gentlemen, what I'm giving you today, what I'm showing you today is something. If I was in an industry and if I had to work with a manufacturing expert, it will be very cumbersome to do these kind of calculations because he would probably be using some sort of a method or Excel sheet which only he is familiar with. Right now, we are doing all of this using a tool which has got a standardized approach to solving such scenarios. Okay, so the next thing that would probably impact, let me be here for a minute, is I wanted to show you that this element called part geometry. Now remember, have a look at this. Yes, we can do it virtually. Exactly, Shanmugha. Now imagine this. If you look at this part, okay, if you look at this part, it's something like this. You can see my screen. So this is 70 and one side is 100. Can you see that? Just remember this. This side is 70, this side is 100, right? Now, I go here, I go to this part projected area. So if I want to, are you able to see my video? If you can see my video, say yes on the chat box. You can. Now imagine this part, okay? I'll come and show you this in the CAD model later. If I want to make this component, I'm going to ask you ABC. This is surface A. Is this a good way to manufacture it? Or should it be good to manufacture like this? Or should it be good to manufacture it this way? What do you think? Will it be A? Will it be this one, the longer side B, or will it should be a shorter side C? A, right? Because this is a larger area, so it's easy to have a molding that can be easy along this axis, along this face, along this face. So I can create this kind of data if I know it. I can click on geometry calculator. So pause for a minute and have a look at my screen. So this geometry calculator is a tool that is built inside our DFMA software, wherein it allows the users to build their geometry to explain or calculate these critical things related to manufacturing their part. So if I want to describe the projected area, this is the projected area whose dimension on the is 70 here and 100 here. I can use something like this as my geometry calculator. I can click on this detail and the software will calculate the projected area. Okay, you see the projected area is showing a 66. I can say this is what is my actual projected area, and I say OK, and it will bring that up. When I bring that up, now I calculate. See the impact. It's going to slightly change the process, and this is going to be my variation. So when you have what I'm also trying to show you is as and when I get more and more data, then I can make my prediction more and more accurate. I hope you're getting it. Now, let me continue and add one more element here. Now, what parameter of this part, if you're seeing what I'm holding up, this plus this is the perimeter, right? So I can go to this outer perimeter geometry calculator icon. Now is sorry. This is my geometry calculator. See, the geometry calculator is slightly different now. Right? Last time we had blue color boxes which were having areas. Now we have a geometry calculator where it is showing lines and line segments. What I'm showing you here, gentlemen, is it's not necessary that you should know all of this. I'm showing it to those who may find this interesting to pursue. If you don't have this kind of data, even this conceptual level, you can get good estimates. Okay, feel confident about that. Now, here's a line segment. So I'm going to say line segment, and I'll click on it and say this is the 100 mm line segment. I'm just giving it a name, which is 100 mm line segment. If you're seeing my screen, the one on the bottom here and this on the bottom on the top. So I will say I have 2 line segments in my rectangular box. The dimension is 100 and the repeat count is 2 because one on the top and one on the bottom. Similarly, I have another one on the left hand side, right? The 70 mm. These are names that I'm giving there in the file so that it makes it easy for you to follow me. So that's a 70 mm line segment. There are 2 such line segments. And I'll say, OK, it comes into my software. Did you follow this so far? Okay, so here's my request to those who have followed and those who are still in doubt but are shy to ask me. The thing is, we believe in DFMA, 2 heads are better than 1. So while I may not have the time to, yeah, that's what I was going to tell you, Hanshal. What I cannot repeat, why don't you look at those who have said yes upfront, connect with them after the session and say, hey, did you understand it right? Can you explain and get that explanation done? Okay, but just in the interest of what I'm trying to give you an overview gist is projected area means in the casting, the direction in which you want to make your part. So when you select or look at a part, you should be able to make a decision, which is a better way to make that component. See, it's easy to cast a component this way on this face side because it is a shorter distance to the whole component being to be made. But if it is made this way, it is too long to make a mold like this or a mold like this. So that is called projected area. That's number 1. Perimeter, which means in the direction your mold is present, what is the perimeter of the part? Okay. So should we not leave some margin if you're making a mold? Yeah, you can take all of that. Gentlemen, I'm showing you the details. The accuracy, the more and more accurate as you input, more predictably close is your engineering cost. Okay. What I'm showing you here is a conceptual level. I'll show you something which we can do much more easily when I do work with the CAD model, which I'm going to do just now in a minute. Okay. So this is one set of information that I have prepared for you here. And somebody asked me about surface patches. This is a very interesting question, and there's an interesting way and how DFM has solved this also. See, what does surface patches mean? If you go and click on the surface patches and you click on this on context help, okay. Normally we have most of our components would have complexity, have features. So how do you define complexity? Can you define complexity to me? You can write some words on the chat box. How do you say my part is complex? Curves, okay. Don't worry about shrinkage, Neil. Just give the part geometry details. Difficult to make shapes, including some assembly, extrusion features. You can go on. Can you give me one definition of how to make it in undefined segments, unsymmetrical? Okay, thank you so much. Time out. So DFM says you can define part complexity by saying how many surface patches your component is made of. For example, if you take, are you able to see my screen? If you take a cylinder, okay, if you take a cylinder, how many patches would it have? One surface, the top surface, bottom surface, 3 patches, right? If you take a regular cuboid, if it's a regular cuboid, you'll have 6 surface patches, 1, 2, 3, 4, 5, and 6. Correct. Now, does your CAD model actually generate a really large cylinder as just 3 parts? It doesn't. 3 surfaces? It doesn't. Actually, it makes many small surface segments, and that is how it describes the component, right? So what DFM has done is, in order to define the part complexity, they are saying if you let us know how many are the number of surface patches that make up your component's structure, that will add to the cost related to molding the negative shape of that part, which is what we add here. So just watch this. Now, right now I have 216 surface patches, is what the software has done as an estimate. If I make it 217 and I press on calculate, see the molding cost from 43,095, it has become 43,260. Okay, so what is the meaning of surface patches is, one, it is used to define part complexity. Part complexity is defined as how many number of surfaces your component is made of. Just like you said, for a cuboid, it has 6 surfaces. In real-time CAD modeling or CNC programming, it is just not 6. It will probably be multiple surface segments that is used to describe the total geometry. Normally, CAD modeling tools have this. That surface geometry count comes here, and this impacts molding. What you need to know is, yeah, okay. Yes, you can consider fillets also. So I also already spoke about the die casting machine. Then let's go and talk about the die casting operation. These are just gists of things. Here, let us say if you are, now I'm doing a different role play now. Yes, complexity is defined as number of surface patches that make up the complex structure. Yes, Anshu. Thanks for cutting pasting that. Now this is a default setting from the database. Now I'm going to do this copy. I'm going to call it paste. I'll call it rename as -IIT Rupar for a minute. Okay. What I'm saying here is at IIT Rupar, our lab rate of machine is not $60. Let us say if you know what is the lab rate, what is the machine rate of the machine that is there in your factory, in your college, or whatever, you can actually go and build that. Okay, it is not $30 an hour in India. It's less than $2 an hour skilled labor in India. So when I do something like this, I can impact and see how it adds up to the cost. So if I make this using the US database, this was my cost impact. Because I changed the machine rate, because I changed the labor rate, you see what is impacting is the material has not changed. The setup cost and the process cost, because of my new labor rate, is slightly lesser, and this is my proposed new cost. So if somebody says, oh, you have to work on a project, there's so much of data to get, don't worry, get your idea of how do you want to make your product right, then you go and build the details that you know about your enterprise. Yes, machine cost includes depreciation. So here's what I will do to show you. Let us say I make another copy of this. I will paste it. I'll rename this. I'll call it as depreciation. Okay, this depreciate. So let us say I go back to my vendor 4 years from now, and I says today is $10. I say no, last time it was $10. At 10% every year depreciation, it should now be $6. Okay, what is the impact of something like that? I can calculate. Okay, so you can build these kind of different scenarios as you go and manipulate your idea of building a product. I have 15 minutes. I need to conclude showing a DF doing the import. So let me go a little faster here. So other scenarios that you could probably do when you're sitting with your vendor is, for example, these are some ideal values for the cycle time related to your activity of casting. But let us say this is not true for your real-time scenario. You can actually go and key in what you think is the actual activity that is there. You would do this if you're a part of an industry. You would do this if you know these values. And as you do this, you will find out this cycle time, and that will help you to figure out what is going to be the impact on your costing, what's going to be the impact of your overall cycle time, and so on and so forth. One more scenario I'd like to tell here, gentlemen, before I move ahead to the next one of showing you the CAD import is sometimes in some places you don't probably pay for the mold. Okay, you just pay for the part. So in that case, I'm trying to go and reset all of these default values of my software calculation to 0. I'm going to press on calculate. You see, my tooling cost has become impacted because of this die cost data that I've just now keyed in at this stage of my process. And thereby, what I have here is the pure cost of my component without the cost of mold cost over it. Now, is it important for you to know this? Well, if you're dealing with somebody who's going to say, sir, I will supply you the parts, but don't worry, I will not charge you the mold cost. This is one way to segregate the costs. Sir, plant efficiency can't be found precisely. So what to do about it? Ronak, are you there from the first session of my class yesterday? Yes or no? Everybody here today is from the session is straight. I told about 2 rules of costing yesterday. Can anybody type that out? No, there are 2 rules of costing. What are the 2 rules of costing? There is no true cost estimation tool in the world. So what you're doing is making it better using as much. Yeah. Okay. So that's the approach again that you need to follow. You have to get as close as possible to real scenarios to build up. See, today in the post-COVID scenario, ladies and gentlemen, most companies are building costing as a strategy to build more efficient products. They're using costing as a strategy to find better materials and process combinations to build their products so that they can serve the customer at the best economical and efficient cost. Okay, so this tool helps to make that decisions more and more sharper. Do you understand? Okay, so now let me go ahead and do the same component that I had. Let me save this first. This DFM. Okay, now I'm going to show you how I could do the same thing if I had a CAD model. I'm going to say import a CAD model. So I can say external CAD model load. So you'll get this accuracy warning. You can say OK and close. I'm going to select this base part. And you would get. I hope you pay some close attention to what I'm showing here. We're going to talk about these. So this is my CAD model in an STP format, which I've imported here. Now I have a question for you guys. Can you see the coordinates at the bottom, X, Y, Z? Okay. Now the question is, which do you think is a good way to cast this component? Is it in the direction of X, in the direction of Y, or in the direction of Z? Y, correct. So this is more feasible from a casting perspective than compared to the other two directions. So what I'm going to do is when I import a CAD model, okay, watch this. When I import a CAD model, the CAD model's overview geometry automatically comes into the software. Okay. What you do have to do as a choice is select the envelope shape that closely represents your geometry. Watch this. You see here forming direction. If I select a hollow, I get a principal axis. If it's a solid, I don't get a principal axis. You get it? So this is a choices which the software will come up with. Make sure you're having the right choice made depending on the geometry that you have selected. Now, another thing I like you to point out to you is as I select the direction of forming, I want you to watch the average thickness. Now, where are these numbers coming from? This number is coming from the CAD model that has been whose data has been transferred into the DFM tool through this STP viewer software. So in the direction of Y, that the software is able to measure that there's an average thickness of 6 mm. In the direction of Z, it's about to see 5.7 mm. In the direction of X, it is seeing about 5.5 mm. Nevertheless, our direction of forming is going to be the Y, right? And in this case, the axis of forming also is going to be Y. Yes. Now, when I do a CAD import, this is what I should take care of. Quantity, the right envelope shape that closely defines my part. This is your actual part. We are a component centric tool. You're a product centric tool. Okay. Here you don't you give the geometry of the part in the final geometry of the part. That's what you give here. That's what has come out here also. Now I select the process and material. Now I select the same process for the same geometry. And say OK. The only difference between my previous to here is a few things. One, if you remember, there are white color, which means default, yellow color if the user is giving information. But if you go to the CAD model generated, orange color will come there, which means orange color data is the data that has come from the CAD software. Okay. All right, let me take a minute and answer some questions from the chat box. Is there any limitation in the CAD software, or we can import it from any other software? As long as it is STL, STP, IGIS format, you can import. Step block would do, can also. You can explore whatever you want, Abhi. Can you import CAD files? Yes, Mridula. That's what I just now showed you. Sir, what if our envelope shape is not in resemblance with any of the given figures? Jai Khan, Jai Kira, you have to closely get your part, no matter how complicated the geometry is. Even if it is like the chair that I'm sitting on, what will be the closest geometry of this chair? The maximum XYZ dimensions, and it is a hollow component. I have to. This is how the software works. You have to get your amortization of your geometry to any one of these choices. The better your choice, better is your prediction. Why is it designed this way? Because it is a tool that can help right from conceptual design up to detailed product costing. So this is how the approach is. Mridula, there is no one way of doing things. I could select step block. I could select this one. You can find out what's the benefit of both by doing multiple copies of the same and seeing how the impact is. Sometimes it does have an impact depending on the kind of selection you make. Yeah, casting axis will separate. If you have casting axis in the direction of the mold, you have faster cycle time. If you have features in the direction of the mold, you have faster parts being made. If you have parts which have features perpendicular to the direction of forming in the mold, then you have to spend more time on making cavities, time for releasing the mold. All that adds up to the cost. There are no limitations, Neil. Just make sure that the geometry that you export is well stitched up. There is no loss in the imported file. Now, normally there will be a data loss depending on how the CAD geometry, the CAD software exports out the model. If you have a data loss, go back and do the export more accurately and get that inside. No, you can't re-edit a step file in the CAD software. So, James, let me go back. I got about 7-8 minutes to conclude this casting session before I hand it over to Balaji for sheet metal. So, here, what I wanted to show you is again these elements we have already seen there. What I want to show you is looking at the geometry calculator when you have a CAD model imported. So I clicked on this CAD geometry calculator. Unlike the previous time, here you will see when I have a CAD model, I get this symbol, which means in this file we have a CAD model. And if I click on it, the software will drag up the CAD geometry. Right now, what I want to do is I want to find out what is the projected area in the direction of forming. You all told me that y is the direction of forming, right? Y or negative y is the direction of forming. Correct or not? So, what I can do is I can put this face here up, and if I go and select this geometry, the face of that area is calculated. Okay, and I can bring that into my analysis like this. So this is my new copy, and if you see again, it is showing orange color, which means the software has picked up this value from the CAD software, and I'm making my prediction a little more accurate. So what was $1.21 is about 1.18 now. Let me make a copy. Let me paste it. Let me rename it as maybe improvement, so that I have multiple files showing the same thing. Again, for parameter, like you said, you wanted to capture the fillets and other features. I can use this geometry. I can build the geometry here, or I can use the CAD software to help me to capture the parameter. Let me orient the part, and I can select using the. Let me show you all the options that I can on this geometry calculator. This one way of doing it. It is capture. Okay, let me remove it out, or I can select a box. But in this case, I don't need these circles. So these do not contribute to the parameter. Parameter means only the outside, not these features. So I can go and say negative and pick this result. Actually, the center hole is called a through hole. Okay, let's focus on my presentation. We will come back to your questions a little later. So there are different ways in how you can use this tool. I'm just repeat it one more time. This is removing every selection. This is picking up every selection. This is picking one by one. Okay, this is removing selection. This is box selecting, unselecting. Get it? So these are the icons that are there. Right now, I'm going to do a quick pick like this. This is my perimeter capture, and I don't want these. Sorry, I messed up this guy. So I'll take the tick box selected, and my perimeter is captured. So this perimeter capture is now, I say, okay, it gets transferred into my DFA in my calculation. Remember that big part that we saw here, the component feature like this. There are two ways to make this part. Maybe I'll take another 5-7 minutes extra if you don't mind. One is I can make this as a part of the casting itself. If I make it as a part of a casting, then this will be called as a through hole. Okay, it will be called a through hole. It doesn't matter, it doesn't matter the selection. If you just select one of the Y, the mold has to go Y and negative Y only. There's no other way it can probably move. Okay, look at this. Watch what I'm showing now. You see this trimming operation. Look at the number of features here. 1, 2, 3, 4, 5, 6, 7 items are listed here. Remember that. Well, 7 items are listed here. I'll show you, and why it becomes more or less, I will let you know. Now, do you agree that we have a through hole in our model, the central big hole? If it is yes, you can do two things. You can type it, and you can give the dimension if you know this. Again, ladies and gentlemen, what I'm trying to show is there doesn't have to be one way of solving things. If I know something from my CAD model, I can even type it here. That's what I'm doing here. You see, I've typed it. So what I've typed is yellow colored user input. What I get from the CAD software is orange inputs. What I have as white is default inputs. Okay, but I'm not satisfied giving this one whole, which I've typed out. I want to get it from the CAD software. No problem. I click on the geometry calculator. I use the geometry calculator. I use this read feature of the CAD model from the geometry calculator, and I will select that. Hey, this is the perimeter of my through hole. See, it's 141 and not 100. So this is a better accurate input. So I can take advantage of the CAD model imports that I have, and I say OK. It becomes orange in color. Get it? Calculate this value. Now watch this. In the trimming operation, if you see, this was not there before. It is not there before. It is automatically copied, calculated, and put it. What I'm trying to tell you, gentlemen, if you keep on building some selections upfront in your hierarchy of your process chart, be assured it will keep on getting captured as you go down and helping you to build a more and more accurate estimate of your product design. So if I give a nutshell of my last 45 minutes of presentation of this part, if I look at the conceptual, but I had an idea of the part, I thought it is going to be 70, 100, something like that. I used it to build my costing, and I kept on improving it. Then I had my engineer who did the CAD model, and then I have the improvised version. So you see, this is going to be my cost of this component. Again, if you look at the conceptual design cost, it was $10. In IIT Rupa case, I changed the machine rate. I localized my cost for internally. In IIT depreciated, I made it much better because in 2021, I know my vendor's cost is not $10 a machine, it is now $6. Then I actually got the engineered component from my CAD team, my design team. So from $10 to $1.99. Okay, this journey, if I didn't have a DFM like tool for a component like this, I have seen companies spend 8 to 12 weeks. We've done it in less than 1 hour. Imagine when people like you have working in teams have this at your disposal, you'll be doing it in minutes. So we'll spend the next 5 minutes answering some questions. We'll spend the next 5 minutes looking at how our concept to different see, and I'm able to see all of this on a dashboard. Right? I can see what the profiles are for different volumes and figure out how the impact is across different volumes. So let's answer some questions over the next 10 minutes. Balaji, can you gear up to do the sheet metal presentation, please? Can you give me a shout out?
Yes, sir.
In the meanwhile, I just Yogesh, can you ask for transfer to Balaji for hosting, and I'll be co-host, and we will answer some questions on the chat box in the meanwhile. So when a company goes to manufacture for a product, in the molding cost, tooling cost, time for production are borne by the company or manufacturer. Depends, Himanshu. These are different business decisions. Sometimes the vendor would say, I will only give you the part, I will not give you the proprietary mold. So it is a decision. Do we as a company also have to reduce one-time cost? Nothing like that. It depends. If you want to own the intellectual property of that mold, you would not want to do it. Sir, can we have these project files? It's already given, Kunal. The project files related for training has been given. If you're increasing the number of cavities, the machine time is optimized. But then why is the tooling investment price increasing? Of course, right. I want to make this part. I have one cavity in which I want to pour the material and make the casting. Now you're going to increase more cavities. You have to machine that cavity in the mold, right? So molding cost, the molding tool, all of that will add up. That's why the cost increases. Sir, if about increasing number of cavities, machine time optimized, I'm a bit infused. Avantika, I hope I explained to you now. The other holes doesn't count as through holes. Great. Good question. Just hold on for a minute. Okay. Okay, that's going to take another 5-10 minutes to finish this. So here's what we're going to do. Good question. But that's going to elongate our time. But I think that should be okay. The question which was that other holes. Praneeth is asking is, see, when I make a part like this, what I actually did and I stopped was about casting this part and this through hole. Actually, component parts like this, these actually, if you remember our video, this is actually a through hole for putting the fastener. So I've actually drilled this hole and then put the tapping. Even this feature, for example, if you can see this, can you see this small hole here? If you remember this, if you have the video, you can play it. The sensor sits over here and the sensor set screw is put here. So the sensor set screw is put here. You actually have to drill a hole. You have to tap the hole. So just for the interest of learning, okay, can I just do this one hole for you guys so you'll get a feel of adding additional, machine tool and doing an action? Can we do that? 10 minutes, we'll spend that doing that. Okay, this is critical for your success. So I'm just going to do this one small hole and I'm going to use the CAD software to help me with the data that I want. Right now, watch. I'm going to say insert a machine tool setup. Insert a machine tool setup. And ladies and gentlemen, what comes up is a set of 1, 2, 3, 4, 5, 6, 7, 8 types of machines. How many machines? How many machines? Good. Only mind is listening, is it? Wonderful. This is a very interactive game. I just love this. Now, are there only 8 machines in our library? No. If you look at our library of machines under this manufacturing profile, look at this. These are a list of machines. And each machine, sorry. Each of these machines has subcategories of machines. Each of them having at least 10 to 15 subcategories. Yes, some of them even much more longer. Then why in the world are we only seeing 8 machines here? 8 machine families here. It's simply, ladies and gentlemen, again, as I said earlier, this is a knowledge tool. Correct. Relevant tools that can be used after a die casting process are the only ones that are available for the engineer to access. That way, it also prevents human oversight and human error of picking up the wrong machines to do their actual task. Okay. I wouldn't call it optimize. I would call it the right set of process to be followed post initial primary process. This is your primary process. What I'm going to do now is my secondary process. Wherein I want to drill a hole and I want to tap that hole. Okay, so let me just take some arbitrarily one machine I've taken here, our machining center. So when I take this machining center from the library of machines, this machine's data comes into my analysis. Okay. So this machine, its labor, basic data, its machine hour rate, its kilowatt hours of the motors that is running, its spindle speed, all that is estimated, which is part of the library comes here. Along with that also comes is the cost for doing setup, loading and unloading. Okay, so if you have a different type of holding device, click on it. You'll see what are the different types of holding devices you can have, and you select it. The impact of that also is highlighted here. Okay, if you have a job that you're going to do, and if you foresee, if you're watching my video, if you foresee that you're holding the job on one type, you're going to do some activity, then you have to undo the job, reorient it differently, continue the activity. Then you will say reversal is there and the reversal is okay. So if you have multiple reversals, the impact of reversal also is calculated. How cool is that? Because many times people miss out this time spent where the operator has to unclamp a part, reorient it, do measurements before it is right, and then start doing the continuation operation. So details like this are also captured in our tool. No, there is no 3D printers in our thing, Abhishek. We have not, our principals haven't standardized 3D printers yet, so we don't have it. Okay. So now let us go and drill that small hole and let us tap that hole. Okay. So I'm going to say insert an operation and machining. Again, I would like to point out to you, if you see this machining operation, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 types of machining operations that it is highlighting. Under machining, do we only have 11 types of operation families? Not so. Let me show you the library of operations. Last time I showed you library of machines. Now I'm showing you library of operations. You see under machining, I got so many different operations. Again, depending on the family of the machine that you've selected here, right? Only those machining operations that will be carried out on this Cincinnati machine will be brought up so that it avoids error and incompatibility. Okay, so this way you are protected as a user, that you don't have to call upon a manufacturing expert and say, okay, I've selected a HMC, what all operations can I do on it? Nevertheless, so I hope you get the drift of what I'm saying. So I'm going to drill a hole. Yes, there are finishing processes. Neil, we're going to come to that in a minute. Since I've anyway started it, I'm going to finish that also. So I'm going to drill a hole. I'm going to add it into my analysis. After I drill a hole, I also maybe want to do a tapping of that hole. Okay. Since Neil has asked for other finishing processes, what I want to do is after I do this machining, I want to do an inspection. I'll add that also. Before inspection, I wanted to measure it using a go or a no-go gauge. Okay, so I'll drag this guy and put it up go gauge. Let me keep inspection later. After inspection is done, I want to maybe do heat treatment or maybe hardening. Maybe I want to clean. Maybe I want to clean first. Then do go gauge. After that is done, I want to probably paint it. There are different types of painting opportunities that are there. Yeah, it's aluminum, so I'll do electrostatic color paint. So I can do, and then after that, I want to pack it in a plastic bag and put it into a carton box. I was not going to do all of this before, but anyway, I can even drag and drop activity like you do in Microsoft Word so that you can have the right sequence of your process chart. Very, very wide. Yes, it is. The idea, Mr. Neil, is that you right from getting your raw materials to finish, do your manufacturing of your part, do the secondary, tertiary operations, finishing your part before it's ready for shipping from your factory. Everything will be done using the DFM tool. Okay, I'm not going to get into these details, but let us look at this machine that we did here and the drilling that hole. This is something you need to watch, and you may want to use this as a part of your project. So I want to drill the hole. Again, if I already know the dimensions, I can just key in the values. Sorry, you can key in the values and do an estimate. So this is the cost of drilling that hole. Or I can click on this dimension. I can click on this measurement from the CAD software, the diameter. You see this option. This is a different icon today. Diameter, and I'll say which diameter I want to measure. I can go to that particular small. Can you see this? I'm going to select the diameter of the arc, select that and say OK. It is directly got it. It is 1.5, not 2 mm. Mr. Syed, it is wrong. To Syed just get an arbitrary input. When using the CAD tool, I got the right input. Similarly, the depth of that hole, I just put arbitrarily as 10. If I use the CAD tool, measure from the software. Let us go to that guy. Do you see? So how intensely, how accurately you want to make the estimation of your tool depends on. Let me just show to you that I've selected it right. The depth is hardly 2.8 mm and not 10 mm. So I would like to pause and also tell you sometimes what happens is at the conceptual level, a design team would say it's a 2 mm laga lega, 10 mm laga lijiye yahan pe, and he would continue his exercise. When it comes to a production guy, he would take the soft model and edit it to be accurate. So this was the old estimate of what my design guy did. This is an accurate estimate of what the production engineer did. If you can imagine yourself, this tool, somebody can key in at the conceptual stage, somebody in the design stage, somebody in the engineering process order stage, somebody in the manufacturing stage. The same file can be spread across all of these people. Mine, it's not just a well-curated software, it's also a well-curated demonstration. Okay, that's how we get the idea across. This is a very, very vast tool. You can do wonderful things with this. As I said, I'm not sure if you see my mission statement. We want as many as our Indian design community to have this so that you can get an unbiased feedback of your design intent. And that's the idea. So similarly, as I said, we can go and do this more and more, but I want to stop here to give Balaji a chance to do the sheet metal part. And so I'm going to copy this data from the previous, and I'll say 3 mm, and we get it done. You can go ahead and play with this, and let's get started with the sheet metal module. I'm going to stop sharing my screen, but I'll be live. Balaji, can you take over, please?
Yes, sir. Yes, sir. Please allow me to share the screen.
Yogesh, can you ask Pushpinder to allow Balaji to share screen? How will it calculate machine time for drilling? Neil, the calculations are in the background. If you have already using the tool, if you see at the background, there are estimations that run. I showed you the operations tool yesterday. Did you see my operations tool yesterday? Why are we tapping when you can directly drill the hole of the dia? No, tapping is for creating the threading. No, you will drill a hole, then you will thread it. If you thread it only, you can put a set screw. Yeah, super. Raj, are you good to go?
I can't able to share my screen.
Yogesh, can you ask? Varinderji, can you do this?
Now you can, sir.
Okay, thank you, sir.
Okay.
It's not about playing with this tool. I mean, you don't know the value of this tool is just to give you a heads up. This tool, a commercial license is about 30 lakhs. Okay, and if you deploy this right on day one with your right product measurement, you can recollect back all the money that you invest on a tool like this. So much of time, money, people skills we save using a deployment of tool. Thank you, Abhishek, for saying that. Very kind of you. I hope you can show us some good projects done by you and your teams. Yes, Balaji.
Hello. Everybody received this PDF, DFM sheet metal analysis. Now we are going to do this DFM sheet metal analysis.
Thank you, Debashish.
I request you to keep this PDF along with you so that you can do along with step by step. So what is the idea? Means we are going to do a DFM for a sheet metal without a CAD. We are having one PDF drawing. With the PDF, we are going to make a DFM for a sheet metal. Through this model, I will explain how to do a DFM of sheet metal without a CAD model. First, partner we have to give us template. Part number and life volume as current in PDF, it will be like 10,000. Please type 10,000. So envelope shape will be resemble like a step block. So please click the step block as envelope shape. Before that, I request you to set the analysis set units to metric. So you please use as a default option for all subsequent analysis. Then click OK. So if you see the PDF, that will be a three dimension will be X, Y, Z. So we have to fit the values in this envelope dimension. So 114 is 7. 33. Average thickness will be chosen as a 2 mm as it is in PDF. So we have chosen the envelope shape and we input the envelope dimension. So we can select process and material. If you see in PDF, the material is chosen as lower carbon steel and the process is curve press. So under the select process, just to go for sheet metal. If you go for sheet metal, there will be sheet metal cutting, sheet metal deep drawing, sheet metal stamping. Just enlarge the icon of a sheet metal stamping. and click the process start press. It's loading. We can go according with BDI North America as a default standard database, and we can choose according to PDF like low carbon steel, cold roll commercial quality. So the process I will chosen as a turret press, and the default manufacturing profile is BDI North America, and the material is low carbon steel, cold roll commercial quality. Please click OK. So these are the rapid feedback of the design intent of the total cost. So we have to feed the values, as DFMA will tell how much data you are giving accurate, the results will become more accurate. So here unfolded length will be there. Will be chosen as 114. Width will be 90. We can go for turret press blank data, area of blank. Please click the geometry calculator icon. So for area, for if you see the PDF, we have to choose as a two rectangular area. In first rectangular area, I have to give the values of 114, 57. And second rectangular area, 114, 33. Please click OK. So you can go for perimeter punch now. Perimeter is nothing but the in PDF, according to PDF, we saw the drawing, the total outer area. So if you have a CAD model, we can select a 4 outer lines, and we can have a directly we can give a value. Without a CAD, we have only PDF value. So I want to demonstrate with a PDF 2D drawing how we will take the perimeter. Just simple, we can take as a 3 line. A first line will be specified as that length, unfolded length will be 114. It will be repeat count will be 2. And I taken another line, that is width. If you see the drawing, it will be that comes under width. That it comes under twice 2 repeat count. And another width 33. It will give us repeat count 2. Please click OK. Then we can go for an volts. Number of puncture volts. Please click the icon geometry calculator. So if as Mr. Sai explained earlier, with a CAD we can import and we can take the diameter of a hole. Now we don't have a CAD but data value. Through PDF we can see and we can have a value. First click the option called circular hole. For a namesake, please type for your clarity diameter 15. If you see in PDF, there will be a diameter 15. The volts will be 4 volts will be there. And circular hole diameter 6. So diameter 6 mm and 2 diameter 6 mm hole is there. So repeat count will be 2. And repeat the step again. Now and I choose the diameter is now diameter 4 mm. So 4 mm diameter I have chosen. It will be repeat count will be 2. Just click give OK. So there will be like 8 holes in a PDF. And we can go for a press break data. There will be an option called number of bends. You go for geometry calculator and click this bend icon. That is asking the bend dimension. If you see the PDF, we have to select the length of the bend line. So length of the bend line will be 114. It will be only one repeat count. Only one bend is there. So please click OK.
Balaji, hold on, please. I think they haven't shared the PDF yet now. Can you please show the PDF file once again for their clarity?
This is the PDF. What I've been with the diameter for 15 mm diameter 4, 6 mm diameter 2, and 4 mm diameter 2. So the diameter of the hole which have been punched have been taken, and this is the length, unfolded length under 114 has been taken, and unfolded width like 33 plus 57 we chosen as 90 mm.
Yeah, I request your participants to take screenshot of this to use it in a while. And I request wherein this I need to unmute Syed sir also.
Participants should not receive anything means as Yogesh told, please take screenshot or note this video for the presentation.
Yes. We're so sorry about that you don't have it, but nevertheless, what Balaji and we are trying to show to you, ladies and gentlemen, is you don't have data, you have an idea, you have a sketch. How do you do a DFM analysis? When you do have a 3D data, which I think Balaji also has a plan to show you the same end plate with the 3D model, how you do it. So we have the best of both of this at ideation stage to do analysis, as well as with the first level or detailed CAD model that is at your disposal. So if everybody is taking a screenshot, let Balaji continue, and then we should take it from there. Yes, Balaji, thank you.
Yes, sir. So what I done according to PDF, like it resembles like a shape like step block, and I gave the envelope dimension and thickness, and I select the process of under sheet metal stamping direct press and default database North America, and material which was low carbon steel cold roll commercial quality, and I given OK. In under direct press, I will chosen given as unfolded length, which is 114, and unfolded width will be 90 mm, which will be 57 plus 33, it comes 90, and area of blank. If it is a CAD model, it will directly import the area of blank, it will come as an orange color. But now the CAD model is not there now, so we accordingly go for geometry calculator, and we have given as a 2 rectangular area. Just select this 2 rectangular area. One rectangular comes under length 114 and one with 57. Repeat count will be 1. And another rectangle area 114, 33. So these 2 rectangle consist of an area of a blank. And another we can go for perimeter punched. Perimeter is outer area. In case of a geometry calculator, we have selected 3 lines. In that first line, 114 is a length which comes under 2 times. Repeat count will be 2. And another length line specified is 57, which comes 2 times. And another line length specified is 33, which comes 2 times. So it totally comprises of a total outer line of a part. That's okay.
Balaji, can you put back the PDF for a minute? The 2D drawing and the expanded unblanked dimension, and use it for explaining, Balaji, so that the team can also follow. You have the unblanked drawing?
Unblanked, no, sir.
Okay. You'll follow what Balaji has done, right? If you look at this rectangular, triangular, I mean this sheet metal component, you see this 33 mm that is there on the right hand side towards your face. There's 133 mm this side, 133 mm that side. Understood? Super. Everybody understand? We're good to go. Yes, Balaji. We have a super team here who's really fast with understanding. Awesome. Yes, Balaji, please continue.
Yes, sir. So a number of punched holes now we have been taken. So in geometry calculator, like diameter 15, 2 holes, diameter 15, 4 count holes have been given. Diameter 6, 2 repeat count, and diameter 4, 2 repeat count. Totally comes around 8 holes. So 8 holes. And if you see the PDF, there will be one bend will be there. So number of bend will be taken in a geometry calculator. We have to define that what is the length of a bend line 140 and give OK. So these are the steps for a sheet metal primary process, and it gives the result of this total result. And you can view this result in executive summary. Just wait for a second, it's loading.
Balaji, are you showing your DFM file? Because I'm seeing only a PDF here. Is it only for me or how? Yogesh, are you able to see Balaji's screen?
Yeah, only his PDF screen is visible now, sir. I think
Balaji,
he's-
your only PDF has been seen from the last 2-3 minutes, man. We're not seeing your DFM file.
No, sir.
No, not yet. You want to repeat the previous?
It's now, sir. Now it's visible.
Only now it is visible.
Yeah.
Maybe you want to restart from where you left off in the last
Yeah,
3-4 minutes.
okay, okay.
From executive summary, you have to redo that again.
Executive summary is loading. This is the executive summary for the sheet metal result. Like a cost breakdown. And then the total cost report. So yes, sir, we can that without PDF, with PDF the sheet metal is finished, sir.
Are you going to show the 3D model?
No, sir, 3D model.
Okay. So what you do is you stop sharing. Can I be given the thing to share, please? My screen. Yes, Mayank. If you have a model which is built with, if you have built your CAD model with bend allowances, you can consider it. Yes, you can also do a comparison of the same process with a different machine. You can make a copy of the analysis and do that. Yeah. Am I allowed to share screen?
Yes, sir, you can share the screen, sir.
No, you are saying, but the out project people have to give it to me yet.
Yes, sir. You can share your screen. Your present.
Still, the share is still not highlighting for me.
Let me check again.
Sundar. I'm still not getting it.
Just a minute, sir.
Sure, sure.
Yeah, now you can.
Okay. Yeah, thank you very much. So I'm just continuing where Balaji left off, wherein I have again as we can import your CAD model. If this is so, in this case, I've imported the end plate, and that is what the end plate looks like. Sorry, it's here. And so we have this end plate, right? Well, to answer the question, right now it has been modeled as a solid model, but if you had modeled this as a sheet metal component, you would see the bend radius here, which is not there in this case right now. And the same thing, what we're going to do here is you will select the envelope shape, you would select the direction of forming that impacts, but since it's the uniform sheet metal component, you will see the same thickness coming through no matter what is the cross section of the forming direction you take. And then when you selected the process and material, you can select any of these opportunities for doing the sheet metal process. Just in the interest of variety, I'm going to change from the turret press that I had here to maybe a laser cut process and the low carbon steel as a component and say OK. So here again, what you would do is you already know how to look at this basic data and the impact of this and how costing is. Let's go look more at the geometry part, which is to make your predictions more and more accurate. So the area of the part, if I click on it, like Balaji showed earlier, you can use any of these solid modeling support tools to generate your model. Or since we have a CAD model here, we can select on the CAD model to be brought in and help us in picking up the right geometry of the part. So the geometry of the part would probably include this area of the part and this area of the part. So I'm captured that here by clicking on it and I say, OK, whatever it is estimated here will come into my analysis. Similarly, for the unfolded length, in this case, it is a right. So if you unfold this part, so this length and this length will contribute to the unfolded length of the blank sheet metal component. Do you follow that? Hello? Where am I? Right. So I'm going to use this and say this part and this one will contribute to the unfolded length. So I've selected those two icons and said yes. And the unfolded width would be probably this part of the component. So I'm going to select that and select this and say OK. And when I calculate, I have this estimation made here. Now, if you look at this right-hand side, the process related details, you can actually build more and more in your process steps, especially in this opportunity of sheet metal with the laser cut processing. If you want to put up additional steps to do some other activity, for example, right now, I've got a one press break here. If I make this a 0, okay, and calculate, you see the press break is gone from the process sheet. So at this level in the sheet metal process exclusively, if you type in options here, those many machines of those capabilities will be brought in and listed under your process sheet. You follow? So If you have not seen why I don't have a feature, I want the tool, this is where you should probably do this in the sheet metal process. Go to the additional steps and select this. Okay. Now you just selected a press break here because we have one bend to do. So where is that bend? Let's go and get it done by looking at these other data that is available here. For example, I have to give the perimeter of this component for cutting. So I will use this on geometry calculator, click on this icon and select. Let me select all of these boundaries of this component to describe the perimeter. Okay, so I want to select that. Right now we have a more regular shape for demonstration purpose, but even if you have a very complicated part, you could do it. Time permits, I will either show today or tomorrow to you. Okay, so that's what your geometry selection of the parameter is, and you say okay. Because you selected, it becomes better. Your prediction is much more sharper now. Let me make a copy. Let me make a paste. Let me rename it. I'll call it production department. I'm just doing a role play. Okay, there are not 20 holes here. There are just a couple of holes that are going to be made. So I can go select this. So somebody asked a little earlier about repeat count. So this is a good opportunity to know about that. So if you see here, I have these two holes, okay, of one dimension. These two holes of one dimension. These two holes of one dimension, and these two holes of one dimension. You get it? So I'm going to use this on geometry calculator support and say this is a perimeter, right? Yeah. So I'm going to say perimeter with this, right? And I will say how many number of holes. I'll say 2 over here. I can add another one. Sorry. Select this. So on and so forth. Okay. And this is the last one. Right? And 2 such holes. So this way I'm capturing all of these holes and I see all the 8 holes are captured here. Can you see it? So this is about holes. What about repeat count? What does repeat count mean? So I could have done this like this also. For example, I can undo this other arc. Okay. And if I put repeat count 2, it will still capture. So I'm putting one portion of the arc and saying I have 2 such repeat counts. So that is the difference between how you want to use to build your hierarchy or capturing this data right. Sorry, this is not wrongly picked. Okay, got it. Super. Very smart. Very nice. And I'm going to say keep this as repeat on 1 and 2. My thing is nice. And we're good to go. So 8 holes. Perimeter is captured. Calculate. See the estimate. Better estimate. Correct. One more copy. One more paste. And rename. I call it with the bend estimated for. So in the laser cutting process, I'll go and say how many number of bends. I click on this bend icon. There are 2 ways I can give the bend. I can just click on this bend icon here and say, type in a value and say 114. That is the length of the bend of the part, if you remember. I could do that. I could input it this way. I get a yellow color faster. No, I'm very keen on doing it accurately. Then let me remove this. I go to the CAD import support and I will highlight the bend. Where do you see is the bend? How many bends do we have here? And which is the bend length? Which is the bend length? This line, right? So I select on it whatever is the measured CAD model, it will pick it up and then say, okay, and I will get it inside. So you have different ways of doing. There's no one way of solving a problem. If you know some answers and it's faster than capturing from the CAD, please go use an input, user input. Okay. The only thing is, it depends on how quickly or early or how much of data you have at your disposal to solve such things. So what I've done here again is right from imported model to a final review. I've done this in a stage-wise manner, and I've got a overview. What I like to show you, which also Balaji was highlighting, is we have several different types of reports that you can generate from the software. Depending on what you want to, you should probably explore this to find out the different reporting options. The reporting file has gone and hid itself inside. Here it is. Okay. Let us look at the whole responses column. This is what you would probably give to your manufacturing guy or vendor to look at it and generate data around. This is a cost breakdown. This is the totals of the analysis. I'm doing one at a time. If you want, you can choose several of them. And so depending on where you are in the hierarchy of things, I'm talking from an industry perspective, you would probably utilize these different menus to showcase the different types of reports that you can generate. Of course, there are some options we'd like to show you how you can probably change the header and footer. You can change the logo, you can change the heading, you can change the this imagery on your reporting format and all of that. But this time not permitting now. So what I will do is if we can post your questions on the chat box. What I thought I should do is yesterday we left off at a certain stage where we wanted to do some parts of the case studies. I thought I will start with showing some things related from the industry perspective. Can I do that? So these are some of our customers. In the meanwhile, if you want to frame some questions and put on the chat box, please feel free to do that. We will take it up or answer today, right now, or answer by email. So this is a 6 or a 10 floor lift by Otis, and this whole bill of materials is a 8,000 part assembly. By making certain recommendations for the structure in which they want to implement this product, which is an equipment in itself, they were able to reduce the part count from 8,000 to 6,000 parts. And this has a name. It is called Design for Installation. It's an own name that this company has given for this activity that they have successfully carried out. Now, for a moment, if you think about 2,000 parts less, 2,000 drawing less, 2,000 engineering validations less, quality control, process planning, manufacturing, vendor, suppliers, distribution, maintenance of warranty parts, serviceable items. So the snowball effect of a simplified product is endless to an organization. Here are some of the names of different enterprises across the world that use it in this industrial equipment space. We of course did a project for some customers. You know what was the challenge we got? The challenge was, hey, I want to make this electrical system in our elevator. It's a 639 parts assembly. Our challenge is we are not able to decide whether we should make it in the USA, where our parent company is. Should we move it to our neighboring country, Mexico, or should we push it to our vendor in China? This is the decision they wanted to make around a product assembly that they wanted to analyze. Look at this product. Do you know India has bought this equipment recently? This is an Apache helicopter made by Boeing. Now, even after companies have launched their products, they are consistently looking at opportunities to find ways to improvise or make it more cost efficient, or make it more efficient from the perspective of reducing weight, or making it more robust, or reducing the cost of inventory for the serviceable items, so on and so forth. Because this is not a cost conscious product, right? Somebody's paying millions of dollars for a product like this. they wouldn't mind a few rupees here and there for a additional cost of the subsystems there. But for a company who's making this, they have different excellence criteria. Let me just show you one example of the tail end of the aircraft here. This is the rear end of the aircraft. Can you make out what this may be? Okay, this is called a bracket assembly. It's called anti-fail bracket assembly. It used to be made of 5 sheet metal parts. I had 20 tools that was required for putting these sheet metal parts for the 19 fasteners, and this used to do consume about 32 hours to manufacture. So a company like Boeing wants to plan, can we move this manufacturing, say, to Vietnam or India or China to manufacture this part? But there are challenges with something like this. Like the intellectual property, the whole drawings have to be moved out to this vendor who's outside the network of the organization, correct? Let us say somebody like in the engineering team recommends, you know what, sir, this is a titanium alloy sheets that are used to manufacture. Why don't we do something like this? We take a big block of titanium alloy. We have 5-axis machining today. Why don't we machine all of these features and make it as a singular part? Making sense? Now my question to you is, do you think it's an idea that will be cost effective or expensive? Do you think it'll take lesser time, more time? Do you think if you're a part of a company or if you were to do this, would you? It will be cost effective? Aditya, you think it's cost effective? More time? Okay. Imagine that if all of us were a part of this design team, how are we going to help our boss to make a decision to say yes to this project? Cost effective manufacturing, cost will rise along with the assembly. Okay, wait. Let me add to what Ashit Bhatt said. Okay. There are not many parts that the product this company makes. They make about, say, 15 to 18 helicopters per year, maybe less. Now you tell me, do you still think it is going to be cost effective? So what I'm trying to confuse you here with is, when we have such kind of data points and we are not able to engineer, today, how do you think companies are engineering a solution of new ways of process or material or taking advantage of newer manufacturing processes, right? Okay, so what all you are saying are similar confusions we have when we go to an industry and do a consulting like this. Okay, and different people, based on their experience, will pull the decision on different directions. But if I have a scientific approach by using a DFMA like tool, this is actually a published case study. You can find it in our principal's website, or we can share it with you. So this is what is going to be an outcome if you were to do a DFMA review of this proposal. So of course, this is a singular part, which is good from an engineering perspective. You don't need tools because the CNC will machine the whole features into a singular block. This is valuable for the company, right? And also it is a flying vehicle, so 10% less weight is a good effect on the overall performance of the vehicle. Now, the bigger decision for a company is, I'm talking, as I said again to you, ladies and gentlemen, like tomorrow, if you go into the industry, how would you want to perceive manufacturing and looking at parts? Why would a company which already has a customer who's paying for their product, okay, invest into something new unless he sees that there's a potential to save? Because after the part is made, it has to undergo certification from the Federal Aviation Agency, military grade certifications, right? To make this product actually work in the hands of the customer. They will invest only if there's a potential to save. So you need to have this mindset that you can't be a separate player just saying my engineering is good, I got 10% saving, I could do it in 2 hours now. That alone may not be an excellence criteria for a product like this. Making sense? It's making sense? Say yes in the chat box. Okay, there are many such case studies I have in the aerospace domain. I can share tomorrow if you want, or we can share with you. But that's the idea. From other domains like office equipment, Dell, companies like these which have serviceable items, they look at design for service. Like earlier today, we spoke about disassembly. Yeah, you can use it, Mr. Tanzim. for Formula 1 student components. Even if you're making one prototype, you can use DFM to find out which is the best approach to getting that component made. Okay, you can do the DFM analysis and see if you make one, how much, if you make 10, how much, if you make 100, how much, what makes a better choice. Yes. No, we don't provide licenses to teams. Your institution will buy the license, and you can probably use that license of the software that is available at your institution. So coming back to the presentation, Dell uses it for designing for service. Okay. Previously, it used to take a lot of time to access a small component on the motherboard. If you're able to see my screen, I'm not sure if you're able to see my screen. I'm just going to play on my table. If I have to access this component, there's a little big motherboard there. If I want to put a screwdriver under it, I can't do it. So I have to remove all of these 4 or 5 bolts along with the cables to move my component away. Then only I can access this motherboard. When I put it back, it takes another 20 minutes to put this. So Dell said, hey, in our assembly line, we are taking 2 minutes to put this. Why is the engineer taking 25-30 minutes? They figure out that he's spending more time removing and putting back unnecessary bulky SMPS unit, and they came out with a design that make it a simple hinge design. So companies like Dell use it for designing for service. There are companies like Digital Equipment, the original inventors of the rollerball mouse. This little component you see here, they do design for modularity. So once you make a module, that module you can sell it as an intellectual property to companies. Companies will buy that module and they will put their own different designs of the mouse, other features to finish their product. So there is different approaches of how DFMA finds deployment in the industry. But usually military grade artillery, heavy automated, etc. are not made upon long-lasting basis. Avantika, I'm not sure where you got that, but I know I've been working closely with defense forces here in India. We work with some of the top defense labs in the country. Your military grade product should last much more in the hands. Even if it's not deployed, it should be ready for deployment. So you may have something sitting in Rajasthan for 7 years. At the 7th year, if you presses the button, the product has to work. Okay, so that requires a little more robustness. Who made the software? Are you there with us from the morning, from yesterday? I just not told you. Dr. Jeffrey Boothroyd and Peter Dewars. These are the people behind the software. It is made in the USA. It is standardized in the by them. It is their method for 40 years of research that is a part of this tool. Okay, so some of the customers, for example, just before lockdown, okay, I and Balaji were there at Whirlpool in Pune. They have a global technology development center there where we deployed this tool. In COVID, you know, many of them are at home, right? So a lot of the things that are happening in post-COVID is tools and tackles to help you to make your home activities faster, including washing dishes. Dishwashers, which are not so much of sale in India, has gained a lot of momentum in the last 1 year because when people like you and me are sitting at home and you have to do this and every day doing the same activity, probably you want something to ease your burden. So a lot of things are happening post-COVID where the impact of product design and the impact of building those products at favorable cost is becoming very challenging and undertaken by many organizations. Okay. Some from the telecommunication industry. There are many case studies we have. A simple case study I would like to tell you is most of you must be having mobile phones. Okay, if you look at your mobile phone, and if you remember the old mobile phones previously, you could actually remove a couple of fasteners and remove the cover and access the battery or the SIM card. Okay, right? Later, what happened was removing this, having screwdrivers in the handbag of a lady to remove screws in an airport where she wants to change a SIM card was a no-no. Many business travelers, they didn't want to have it, so they came out with the snap fit design, which was very common as a part of the mobile phone. You know, you just snap fit a design. So you unsnap it, you can remove the battery, you can access the SIM card, change the SIM card, put back the battery. Correct? Today, have you noticed any of most of your mobile phones? I can assure you, out of the 160 people who are sitting here, more than 90%, 95% of your phones will not even be able to remove your cover. Battery cannot be removed. You know why? That's again a business decision. Why should the customer remove the battery? If the battery goes dead, let him throw away the mobile phone, buy a new one. So that is the advent of improvising how the user experience can define how a new product would be introduced. There is, I can talk about this for 4 hours just on this kind of a concept alone. So the user expectations defines. Before I go ahead, I'm at 10:58 on my watch, at 11 o'clock on my watch. How much of more time do I have with you guys? Can the organizers tell us?
Yes, so we have a next lecture at 11.
So what I'll do is, if this is interesting, I'll keep this for now. Maybe tomorrow I'll ask for another extension of 15-20 minutes just for the sake of covering these aspects. And we'll talk about these case studies, especially from a academic perspective, so that the takeaway for the audience is.
Yeah, Mr. Syed, good morning. I wanted to tell that if you want to take more time, it's okay, because the next slot is for our internal discussion with students that we can delay, no problem. So you can take like 10-15 minutes more now also, no problem.
No, I don't mind, but I don't want to bore the students to the point that they say, "Arey yaar, ye stop hi nahi kar raha hai," matlab, you know.
No, I think anyway, we have put a break for them after your talk, because
Okay.
we got some messages that it is too extended yesterday. So we are going to give them 15 minutes break after your talk. So don't worry, you can
Okay.
take it. Okay.
So yeah, so let me just talk around these case studies and then continue. We were here at this telephone. So, ladies and gentlemen, what I'm saying is, when you join different organizations, even different organizations will have a different approach. Even your own projects that you undertake, you should be able to deliver what kind of a user experience you want to give with your product that you're offering. So this mobile phone is a very great case study. I mean, let us say in my college days, I could not imagine buying a mobile phone for 30,000-40,000 rupees. That would be somebody's salary for about 2.5-3 years, I think. But today, the whole product is designed in such a way that they give you best of experience. But when the product is not working or not functioning fully to its potential, the user expectation is get rid of the mobile phone and get something new. Right? That is built into how the structure of the product. How do you do that? That's, you never have to service the product for whatever extended life that you're offering is something that you do. Like somebody asked me earlier about military products, they would say, give me a 7-year shelf life, which means it could be on a ship, it could be on under the wing of an aircraft. For 7 years, they'll never fire that missile or never push that button of the torpedo or something like that. But when they push that damn button, it should very well work. So 5 years, 7 years, 10 years is the performance expectation of the product. So if you're putting something inside it, like ammunition, if you're putting inside it like a battery, if you're putting inside it like electronics, it has to withstand the air, marine, or salt, or whatever that it is being subjected to. And when they press that activity that is required for that function to work, it should work. So these different excellence criteria are the drivers on how you take up what you want to do with the DFA activity or the DFM activity. Okay, so it's not a one size fit all. Okay, it's not a one-way approach to solving problems. And again, if somebody talks about costing, you can tell them, hey, there are 2 rules of costing. One, there is no true cost estimation tool in the world. Second, if in case of doubt, refer to rule number 1. So the other customers from our domains which have deployed DFMA from different industry, including medical, automotive, we have a team number of case studies. Sometimes customers, this is Harley Davidson that is here, want to benchmark or get features of their competitors. So the sales team would give a capture of their design ideas from the competitor and say, hey, design team, this is a good feature that the competitors are having. If we also have it, it will be probably good for getting more sales of our product. So rapidly, design teams would see whether that feature can be incorporated right away in the existing design, or should they explore it in subsequent new futuristic designs that they would undertake. These are some customers worldwide. These are some customers in India that we have listed out here. Now, this is an example of a air conditioning unit used in automobiles. This is the original design of the product built by a company called Navistar. 202 parts. Yes, AC number of components, bill of materials that is. On the shop floor, we're taking 342 assembly steps and assembling in 38 minutes. Okay. Revised design after many iterations using DFMA, 47 parts. That's how much? Hardly 20% of the original design. And takes only 87 steps and assembles in 8.2 minutes. You take this 38 minutes and you divide by 8.2. What do you get? Can somebody give me an answer? 4.63, 4.8, right? Which means in the same 8-hour shift, your operator is able to assemble 4.6 times more number of AC units compared to the previous design. Without escalating salary, without escalating burden, okay, you're getting 4.6 times more number of products assembled. That's why if you see comparisons of certain cars, about 5 years ago, the car was about 5 lakhs. Today it is about 4.5. How are they doing it? Because they're trying to bring about simplicity in or efficiency in how they assemble their subsystems. And automotive is a very good case study for such examples. I'll just end up in the next 5-10 minutes showing a few case studies from these are some names of our customers from the who I work very closely. That's why it's listed here. Now, this is a case study done by one of our student community. What is this product? This is a torchlight, right? What is it supposed to do? It's supposed to give light, isn't it? Now, in order to get light, how do you get this to work? You have a chemical energy converting to electrical energy called battery. You have a electrical energy getting converted to light energy through a bulb. So conventionally, if you look at the minimum part criteria, if you remember minimum part criteria from yesterday, you should only have 2 parts: a battery that connects to this chemical energy to electrical, electrical to light. But why 17 parts? You see, if you challenge something like this, now there are 2 batteries that can drive 1 torchlight here. And so according to part count reduction, you should probably, it will be good to have 1 battery itself. But just because you want to make a simpler product, you can't go start a battery factory, correct? Let us say that these 2 batteries we cannot change because you definitely need 2 batteries to run this product. With that, and this one, that is the super system. That is the super system here in this case is this battery and this torchlight, which is required for the function of this torchlight to work. This graduates team have come out with an idea of simplifying the rest of the structure so that from 17 parts design made by an OEM like AWaDH, they could come out with a 6-part design complete with mold drawings and so on and so forth. Right? And also I told you an example thing, you need what these 2 parts for the actual product to work. Ladies and gentlemen, I'm not saying let us go make cheap products. India should not be known for that. What I'm just saying, there must be another way of doing things, and that is what this is. What I'm trying to highlight here. Okay, making sense? Another set of students project which I like to show as examples is, yeah, it will take time. You will combine parts and it will take time, but once you have a combined part which is efficient, you make the product at much lower cost. That's what is the key to success. Look at this component. This is a sub-assembly. Let us say you keep this brake assembly drum as a required functional component. Look at the number of parts here. There are 1, 2, 3, 4 set of spokes in batches of 1, 2, 3, 4, 5, 6, 7. Sorry. 1, 2, 3, 4, 5, 6, 7, 8. 9 fours are 36 spokes, 36 nuts, 36 washers plus 1 rim. Okay. Now I have a question for you. Have you seen this kind of a wheel? If you have to assemble, you need a truing tool to assemble and align the wheel to be perfect. Now compare this to a magnesium alloy wheel. My question to you, ladies and gentlemen, is which of these 2 designs is more expensive to manufacture? No, you tell whether the spokes design is expensive or magnesium alloy is expensive. Some are saying spokes, some are saying magnesium alloy. But when you go to a showroom, right? If you go to a showroom, if you go to TVS showroom here in Chennai, and if I go there, the guy says, here's a spokes wheel design. This bike is 30,000 rupees. The same bike with magnesium alloy wheels is 35,000 rupees. Why does he do that? If I go, appeal, exactly. If I go, like Abhishek says, he will not care what I buy. But if Abhishek goes to a smart guy, he says, sir, why up 30,000 ka dekh rahe hain, matlab aapka image kaisa hoga, sir, aap IIT Rupar ja rahe ho. I mean, this goes with your, so, but is that the reason? The thing is, if you do a DFM analysis, this magnesium alloy wheel will work out to be less expensive compared to the spokes wheel design. So this perception of value, there's another thing that customers have, just like the mobile phone that we spoke about earlier, that drives why they make choices in picking up products, right? So things like this also drive how the design is determined at this stage of your product development cycle. And DFA, DFM can aid your process. Understand? So I think with that, gentlemen, I'll take a break for today. Leave the option open for questions. I also have a little announcement to make about. So I'm not sure if Dheeraj, you allow me to give this. I was having a talk with my Dr. Dheeraj. Are you here online? Maybe Varinder or our team could give them a feedback later. I was talking to my startup team, and they said in case there are internship interest from our audience here, they could write to me, or they could write to my colleague Arul, who's from HR. And when you write, you can probably write in your
Yeah, Mr. Syed, I'm there. I'm sorry, like this WebEx co-hosting is a little troublesome for
okay,
me.
Dheeraj, sir,
Yeah,
I was
I'm
just
there.
telling.
I'm there. Yeah, yeah. Please tell me what we need to discuss.
So what was doing yesterday? I was just sharing this thing about our team about this presentation and this event that I'm doing for IIT Rupa. And
Yeah,
they said I was telling that about the whole thing is about the internship challenge. So
Yeah,
they
yeah.
said, hey, why don't we have them write to us in case there's an ideation that could probably where we could be a part of it. So I'm just sharing my email address here, which I've highlighted in yellow. If somebody has to write as a group, or you want to write, you can probably say, "I'd better idea." I mean, I came up with this only this morning. I'd better idea from we could say better idea from IT Rupa, and send us a idea, and maybe we could talk to the board, and we can come back and say yes or no and be a part of that internship. Just something, because our work at the startup in electric tractors is correlating to your event's title. So if this makes sense, I just thought I will share that before I call it a day.
Yeah, we can do that, but somehow they have to sign actually this internship, since we are targeting the patented work. They will be signing NDA, non-disclosure agreements also, these students will be doing. So we'll see how it goes. But your email is always there, and kids have really enjoyed it. They will be getting in touch with you, I'm sure.
Sounds good. So this was an idea that came up, and I thought I should not miss out on sharing this idea with you and the folks. So yeah, we'll be happy to open up an NDA MOU. We have a couple of them with some other institutions as well. So we can do that. Yes. Yes, Jaideep. This tractor is completely built up, ground up. Yeah.
Okay.
With that, I'll leave the forum open for questions for the next 3-4 minutes, and then we call it a day. I'll stop sharing my screen and keep this open for questions. What exactly do you have to express in the mail, sir? Avantika, in case you have an idea which makes aligns to this concept of agri or agri basically, because that's what we do, then you could probably send us an interest for internship, of course, through Dr. Dheeraj and the right mechanism, that is. Please say one time. What do you want me to say? My email address. There are two email addresses. One is if you're going to write about internship, then they should probably send it to site@celestial.com with a copy to arul.kumar@celestial.com. Okay. I'm leaving that screen open. Do we have to share CV or SOP in this? I do not know. I just an idea. Don't get so into details. Whatever you want to share, you share. Arul will take it from there, and we will. Yeah, from there. Okay. Any other questions related to today's presentation? No, shall we call it a day? You'll have a good rest of the session for today, and we'll touch base tomorrow morning at 9 a.m. Yogesh, can you see Soumik's question, cost and excellence criteria? We'll answer it by tomorrow. Soumik, can you send us an email to this effect at support, a little more detailed, and we'll answer it? Thank you. So thank you so much, guys. Have a great day and see you tomorrow. Bye-bye.
Okay, sir. I would like to thank and Mr. Balaji for giving a knowledgeable lecture which gave deep insights.
Varinder, your voice is not audible. You're not audible.
Am I audible now?
Yeah.
Yeah, much better. Yeah.
I would like to thank Mr. Sahib and Mr. Balaji for giving a knowledgeable lecture which gave deep insights into a topic by using case studies. Thank you so much, sir, for your knowledgeable lecture.
Thank you.
Yeah.
Thank you, Virendra. You're
Yeah.
welcome.
Thank you, Mr. Syed. See you tomorrow then. Okay.
Thanks, Dr. Vyas. Bye.
Bye.
Bye, everybody.
Mm. So, students, please be ready. You are going to get an email in next 10 minutes, which is a Google form. You need to submit like your latest CV in that, and your contact reference contact information. So please get your CV ready. You will be receiving an email in next 10 minutes, and then you guys have to submit that Google form latest by I think 2 p.m. 2:30 p.m. That submission is very important for getting the details from you. Thank you. So it's a rest period now. We will start at 11:30.